Quantlay's Research and Development Center, we are exploring a new direction in intelligent computing. PIPU, the Photonic Intelligence Processing Unit, is QRDC's physics-native platform designed for complex, continuously evolving information using the dynamics of light as part of the computation itself. PIPU is not intended to replace GPUs or conventional AI. It is designed to complement them by adding a more adaptive, context-aware layer of intelligence, helping systems respond not only to what the data predicts, but also to whether the conditions behind that prediction are still valid. We are entering an age where data is not only becoming much larger, but is also constantly changing and increasingly unpredictable. Traditional computing is extremely powerful, but the real world does not always behave in a fixed or predictable way. This is where PIPU takes a different approach. By using the physics of light, it is designed to work with complex, changing, and uncertain information, bringing a new capability alongside conventional AI and computing. The very rapid growth of artificial intelligence is creating enormous demand for more compute, more data movement, and more energy. As these demands increase, no single computing architecture is likely to solve every problem efficiently. This is why we are seeing investment spread into several new computing paradigms. Traditional AI compute remains the foundation, while specialized inference processors are making AI faster and more efficient. At the same time, photonic accelerators, quantum computing, and physics-based computing are emerging to address different classes of problems where conventional architectures may face limitations. The important message is that these technologies are not necessarily competing with each other. The future is likely to be a heterogeneous computing ecosystem where GPUs remain central while specialized technologies provide complementary capabilities. This is the landscape in which PIPU is being developed and positioned. Now, a very interesting picture is that the intelligent computing market is expanding rapidly, but importantly, the growth is happening across several different technologies rather than around one architecture alone. AI compute remains the largest foundation, while AI inference, photonic acceleration, quantum, and physics-based compute are developing as complementary markets. What this shows is a very clear movement towards specialized and heterogeneous computing. Different technologies will address different types of problems, with growing emphasis on energy efficiency, adaptability, and real-world intelligence. For PIPU, this creates an important and a unique emerging opportunity. Physics-based computing is still an early market, but it sits within a much larger shift towards new forms of intelligent infrastructure, giving QRDC an opportunity to build capability while this ecosystem is still taking shape. The next major shift is from simply having more compute power to having intelligence that can respond as conditions change. Data is growing, decisions are becoming more time sensitive, and moving and processing all that information is increasingly expensive. This creates an opportunity for adaptive, physics-native compute. Instead of relying only on previously learned patterns, these systems can work with complex, uncertain, and continuously evolving information, where real-time adaptation and probabilistic behavior become increasingly important. That is the opportunity PIPU is designed to address. It complements existing AI infrastructure and GPUs with a different capability: intelligence that can respond to evolving conditions, opening a new layer of value across finance, energy, mobility, healthcare, and other dynamic environments. Here, we move from the market opportunity to what PIPU actually is. PIPU is QRDC's physics-native photonic compute platform. It is designed to transform complex time-varying information into adaptive intelligence using the physical dynamics of light. The system follows a continuous process: encode, process, sense, and adapt. This allows PIPU to work with nonlinear, uncertain, and changing environments in real time rather than relying only on a fixed computational response. Most importantly, PIPU is designed to complement existing GPU and AI infrastructure, not replace it. Our vision is to develop it as a new layer within the emerging infrastructure of intelligence, bringing physics native, adaptive, and probabilistic capabilities to problems where conventional compute alone may reach its limits. This is where we show where exactly PIPU sits within the broader compute landscape. Digital AI, optical accelerators, reservoir computing, and quantum computing each have different strengths and are designed for different classes of problems. PIPU occupies a distinct position. It combines physics-native photonic dynamics with probabilistic and adaptive processing, making it particularly relevant to complex, non-stationary, and uncertain information where conditions can change over time. The key point is that PIPU is not competing to replace existing infrastructure or these technologies. It adds a complementary layer of a unique capability. So the future is not one architecture replacing another, but different compute paradigms working together to create more capable intelligent systems. This slide explains how PIPU works physically. A coherent laser beam carries the input through the spatial light modulator or SLM and optical elements where interference, diffraction, and complex photonic dynamics transform the information. The camera then captures the resulting optical states. What makes PIPU particularly interesting is the closed feedback loop. The measured output is fed back into the system, allowing the optical states to continuously evolve rather than performing only a single fixed calculation. In simple terms, light becomes part of the compute process itself. Through repeated sensing, feedback, and adaptation, complex optical states can converge towards useful computational representations, providing the physics-native foundation behind PIPU's adaptive intelligence capability. Instead of treating light simply as a way to carry information, PIPU uses properties such as coherence, interference, diffraction, and nonlinear dynamics to actually process that information. These interactions create rich and diverse optical states. Through controlled entropy and operation near the edge of chaos, the system has enough stability to retain useful information while remaining sensitive enough to respond when new information or changing conditions enter the system. So the key idea is quite simple. PIPU turns the natural physics of light into a computational resource. With sensing and feedback closing the loop, these physical dynamics provide the foundation for probabilistic and adaptive intelligence capability of the PIPU. Instead of treating light simply as a way to carry information, PIPU uses properties such as coherence, interference, diffraction, and nonlinear. The UAE is rapidly building a powerful ecosystem for sovereign intelligent compute, spanning advanced research, AI accelerated compute, cloud infrastructure, and large-scale data capability. Together, these capabilities are creating the foundations for the next generation of intelligent infrastructure. Within this ecosystem, QRDC is developing a distinctly different capability through PIPU, bringing physics native, probabilistic and adaptive compute into the landscape. Our objective is not to duplicate what already exists, but to add a complementary intelligence layer that can work alongside the UAE's growing digital and AI infrastructure. This positions QRDC to contribute something genuinely differentiated to the UAE's technology journey, developing new compute capability from within the UAE with the potential to become part of the wider infrastructure of intelligence. The PIPU has been built through a combination of scientific vision, strategic direction, and hands on engineering teamwork. The program brings these capabilities together, from defining the underlying photonic compute concept to positioning its real world value and finally turning that vision into a working experimental system. What makes the team structure important is that research, product strategy, and engineering execution are connected rather than isolated. This allows the PIPU to move systematically from laboratory physics towards a credible compute platform with measurable results and real world relevance and impact. Ultimately, PIPU is the product of one integrated mission, turning an ambitious scientific idea into a technology that can be experimentally demonstrated, validated, and progressively scaled.